In this video, I'm going to talk about the second aspect of chapter 15, where we are covering um, mm, organic compounds known as haloalkanes. And in the previous video, I talked about um, the reactions that I use to make these haloalkanes. But in this video, we are going to focus on their classification. That's the grouping of this class of organic compounds. So we have haloalkanes being divided mainly based on the number of um, halogen atoms uh, that they contain. So we have those that only have one halogen atom in their molecules, these are known as monosubstituted haloalkanes. Examples these might include compounds like chloromethane, bromoethane, iodo propane. All these are monosubstituted as long as there's only one um, halogen to carbon bond. As long as there's only one carbon to halogen bond in the molecules, then they are known as monosubstituted haloalkanes. But if now the halogen atoms present in the alkane molecule or in the haloalkane, if it is more than one, then it's now considered or regarded as a polysubstituted haloalkane. Examples include such compounds like 1,2-dibromo ethane, something like this. 1,2-dibromo. Let me just draw the structure and then I will show you. Dibromo ethane. This is the structure of 1,2-dibromo ethane, something like this. So because it now has two halogen atoms in one molecule of the compound, then this is referred to as a polysubstituted haloalkane. So now these monosubstituted haloalkanes are further divided into three groups. The monosubstituted, those that I've said contain only one halogen atom in their molecules. They are further divided into three. The first group of these monosubstituted haloalkanes is called primary, or rather such haloalkanes which have only one halogen atom, such that the carbon atom that is directly bonded to the halogen atom is also bonded to one alkyl group. When we have got such a haloalkane in which the carbon atom that is directly bonded to the halogen atom is bonded to only one alkyl group or to two hydrogen atoms, this type of a monosubstituted haloalkane is known as a primary haloalkane. That is if there's only one alkyl group attached to the carbon atom which is directly bonded to the halogen atom, or if there are two hydrogen atoms attached to that carbon, then it's a primary haloalkane. And if there are now two other groups, these are alkyl groups. If the carbon atom is bonded to two alkyl groups, or if there's now only one hydrogen that is bonded to the carbon atom, then that type of a haloalkane is known as a secondary haloalkane. Then we also have the haloalkanes that are classified as tertiary haloalkanes. These are those in which now the carbon atom, which is bonded to the halogen atom, being also bonded to three alkyl groups, or this carbon atom has no hydrogen atom that is directly bonded to it, and such haloalkanes are known as tertiary haloalkanes. So we do have different examples of these three types of haloalkanes or monosubstituted haloalkanes. An example of a primary haloalkane, which I've said the carbon atom that's directly bonded to the halogen atom will be bonded to two hydrogen atoms if it is a primary, or that carbon atom should only be bonded to one alkyl group, then that is a primary a primary haloalkane. And an example of such is chloromethane here. You see, there's only one alkyl group bonded to the carbon atom that is bonded to a halogen atom. And in the other, the secondary now where we have two alkyl groups. So you have got one, two, three carbon atoms in that compound, and it is the middle carbon atom which is attached to a bromine. So this middle one is the second carbon. So when we are naming the haloalkanes, we indicate first the position of the halogen atom, and then we separate the number and the letters with a line, horizontal line like that, and then we write the name of the halogen present in the organic compound. But remember, when we are writing the name, we replace the INE in the name of the halogen. We replace that part with an O. So, say for example, fluorine is then written as fluoro. Bromine is then written as bromo, and then we write the name of the alkene that contains the number of carbon atoms in the compound. As an example, in this compound, the alkene that has the number of carbon atoms present in the compound, which are 1, 2, 3, an alkene with three carbon atoms is called propane. That is the reason why I have written propane here. The ending part of the name of a haloalkane should contain the name of the alkene that has the same number of carbon atoms as indicated in the longest straight chain in your molecule. And if we look at the other example here, which is now for a tertiary haloalkane, and as I've said, in tertiary haloalkanes, the carbon atoms, the carbon atom that is directly bonded to the halogen will be bonded to three other carbon atoms, or it won't be bonded to any hydrogen atom. There won't be any hydrogen atom bonded to that carbon atom. That's a tertiary. So like this one, it has how many carbon atoms? 1, 2, 3. So it's still propane. But the propane, which now has a methyl group on the second carbon and the halogen. So we're going to write 2 methyl 2 chloropropane. 2 methyl 2 chloropropane. That. So that's how we classify haloalkanes. We classify them first by the number of halogen atoms that are present in one molecule of the haloalkane to have monosubstituted haloalkanes, which I've said these will be having only one halogen atom in their molecules. And we also have the polysubstituted haloalkanes, which I said these have two or more halogen atoms in their molecules. And the monosubstituted, which we said they have got only one halogen atoms, further classified or further divided into primary haloalkanes, secondary haloalkanes, and tertiary haloalkanes, and their difference is with the number of hydrogen atoms or alkyl groups that are bonded to the carbon atom, which is directly bonded to the halogen atom. If there are two hydrogen atoms or one alkyl, then that is the primary. If there are two alkyl and one hydrogen, then that is a secondary. And if there's no hydrogen, three alkyl group, then that is a tertiary. That's all for this video. Thank you.